Hi class, today I'm going to teach you guys how to solve for tension forces with angled ropes. First, let's do some review. If I asked you guys to solve for the tension in these ropes and these problems, hopefully it'd be review. Your first step would be to draw a force diagram, FG, and then we've got the rope pulling up on that 10 kilogram block. At this point, we would go F net equals M times A. I would assign upwards to be positive and downwards to be negative, and we would go Ft positive minus Fg equals M times A. At this point, we could start plugging in numbers. So we don't know Ft, that's our goal. Fg is a formula that you should know by now, so the mass times 9.8 equals the mass, and our acceleration here, as far as we know, is 0. And in fact, all our problems will have an acceleration of 0 today. So we could do Ft minus 98 equals 0, and Ft equals 98 newtons. Should be pretty straightforward. The object's not accelerating, there's one rope, so if gravity pulls down with 98 newtons, then the rope must be pulling up with 98 newtons. Over here, you could probably guess the answer. We've got a gravitational force down, and then we have two ropes pulling up on that block. And we're assuming that the object's at rest, and that the forces in the ropes equally hold up the weight of the block. So you could again go F net equals M times A. We've got two tension forces going up in the positive direction, so two positive FTs minus Fg equals M times A. I'll combine those and do 2Ft minus the 98 newtons of weight equals 10 times 0. 2Ft minus 98 equals 0. And just like you would think, now that we have two ropes, each one is holding up half of the 98 newtons of weight of the block. So those are some simple, straightforward problems from our forces chapter that you guys should know. But now we're going to move on to what happens when we have ropes that are an angle, which makes the problems a lot more complex. But you guys will have all the skills to do these. So our goal here is to solve for the tension in these two ropes here, in this rope FTA and FTB. So I'm calling them tension forces in ropes A and in rope B. Your first step is to always draw a force diagram. So I'm going to say Fg pulls down, this rope B pulls up and to the right, and this rope here, A, pulls to the left. Your next step is to always draw your triangle around the angle theta. So this rope pulls up and to the right, so that is a force to the right, and this is going to be a force up because that rope is also pulling up. We now need to identify that this is the adjacent leg and this is the opposite leg. Therefore, the adjacent goes with cosine, so that would be FTB times the cosine of theta, and this force going up is going to be FTB sine of theta. So you get a bunch of points for just doing that. Here's where we start to solve for the rope forces, FTB and FTA. Let's also note that the acceleration is 0 for all these problems. You're going to want to pick horizontal and vertical. I'll just choose vertical. I tend to do that often. Okay. We are going to write out F net equals MA, and we're going to see if we can solve for anything using F net equals MA of our vertical forces. You have to identify that there are only two vertical forces, F of G and FTB sine theta. We are no longer going to use just FTB. Once we broke it up, like we've done in previous problems, we only use the sine and cosine. We no longer use just FTB anymore. We have two forces. One is going up, which I'm going to make positive, and we have one going down, which is negative. So just like we did with the problems above, we've got FTB, positive FTB, sine of theta, minus FG, and because there's no acceleration, I'm just going to make that 0. Now FTB, I don't know. That's one of the things I want to solve for. I do know that the angle theta is 40 degrees. That's given in the problem. And f of g, well, that's mass times 9.8. So 20 times 9.8. And that's going to equal 0. So FTB sine of 40 degrees minus 196 equals 0. FTB sine 40 equals 196. Now, some of you guys may not know this yet because you're not in Algebra 2 trig, but the sine of 40 is some number that's less than 1. So what we can do is we can just divide by sine of 40 degrees. Sine of 40 degrees. And 196 divided by the sine of 40 is 304.92. So FTB equals 304.92 newtons. So we were, I don't want to say lucky, but we were able to solve for something. If we would have started off with horizontal, we wouldn't have. But we only solved for the rope, the tension in rope B. We want to solve for both, which means we are going to have to use horizontal forces because, as you can tell, A is pulling horizontally to the left. So if we look at our force diagram and we start off with F net equals ma, like I always tell you guys to do, we have to look for horizontal forces. Here's one horizontal force that I just put in blue. Here's the other horizontal force right there. There's only two. I will assign the force to the right to be positive. So I'll say positive FTB cosine of theta minus FTA equals, and again, our acceleration is 0. By the way, you could flip those. You could do positive FTA minus FTB cosine theta, and it wouldn't matter. Because our acceleration is 0, you can assign any direction to be positive or negative. And at this point, you're 90% of the way done with the problem. It just becomes number crunching. So I know FTB. That's from what we just got, 304.92 cosine of 40 degrees minus FTA. That's what we're trying to solve for, sorry. That's the tension in rope A that we want to know. How much force is that rope pulling with? Equals 0. And then I can just bring that to the other side. So 304.92 cosine of 40 equals FTA. And therefore, FTA, when you go to your calculator, 304.92 times the cosine of 40 gets you 233.58 newtons. You might want to stop there and think about how I solved that. Maybe you could try that again on your own and rewind it from before I started the problem. Hopefully that made sense. Again, a really important part here is drawing the force diagram, breaking up your angle into sine and cosine, and then going vertically or horizontally. I tend to start off doing vertical forces, looking to see which forces are vertical and looking to see which forces are horizontal, and then going into F net equals ma. So getting to this step right here is the most important part. That's where the majority of your points come from. And same with right here. And although you see me doing a bunch of work here and a bunch of math there, it's worth way less than the rest of the problem, the drawing the force diagram and writing out these force expressions that I just labeled here with a green arrow. So that's the most important part. Okay, I'm going to go ahead and solve one more problem. If you think you're good here, you can start on your worksheet. But I'm going to do one last problem here that's actually going to be a little bit easier. Here's another problem, guys, where we have a block or a sign, whatever it is, attached to a wall. We don't know the mass of it. We don't know how heavy it is, but we do know that there is 6 newtons of tension in rope B. Our goal is to solve for the tension in rope A. First, you always want to draw a force diagram, so I'm going to draw that. So I'm going to put that maybe here in purple. So we've got gravity pulling down, we've got rope A pulling to the right, and we've got rope B pulling to the left. I made my angle theta here a little different than before. This is relative to the vertical, so I'm going to draw my line up here and right there. So this right here, this leg that I'm drawing vertically right here, that is my adjacent leg. So that's going to be FTB cosine theta. And this right here that I'm highlighting, drawing thicker in purple, that's going to be my opposite leg. So that's FTB sine theta. So if I look, I have horizontal forces here, FTA, and this one right here, FTB cosine theta. And my vertical forces are FTB cosine theta and FG pulling down. Our goal is to solve for FTA. We also know this tension force right here is 6 newtons, like I just wrote. So we don't have the mass, which is fine. We can still solve for the tension force in A. I'm just going to go ahead and start off using vertical forces. We may get stuck here. We'll just see. So vertically, and again, the acceleration is 0 here. This object's not accelerating. I'll do F net equals m times A. And then we have FTB cosine theta. So I'm going to make that positive because that's going up. And then I'm going to subtract off FG, and that's going to equal 0. The problem with this is that right away I realize that I don't know FT. Well, actually, let's see. I know FTB. That's actually 6 newtons. So it's 6 cosine, and then I put my angle over here. 6 cosine 50 minus FG equals 0. And then FG, if I bring that to the other side, is going to equal 6 times the cosine of 50 degrees. So I could solve for that. That may or may not help me out. We'll see. 6 cosine 50. 3.86 newtons. So at least I found FG. Again, that may not help me out. We'll see. Now let's go to horizontal. Horizontally, we'll go F net equals m times A. And then our horizontal forces, again, there's no acceleration, so it doesn't matter which one I choose as positive. I'll just choose to the right as positive. So FTA, that's right here, minus this force, FTB sine theta. And that's going to equal 0 because there's no acceleration. So FTA minus, and again, FTB is 6 newtons. That's given right here in the problem, times the sine of 50 degrees that I gave you up here, equals 0. And FTA, I'll bring this to the other side. FTA equals 6 sine of 50 degrees. I brought this over to the other side. So then at this point, I can just go to my calculator. FTA equals, and then 6 times the cosine, or sorry, 6 times the sine of 50 degrees is 4.59. So it turns out that I didn't need to do the vertical forces. Now, in a test situation, I could ask for FG and we solve for it. In this case, we didn't need it, and we could have just done the horizontal forces to solve and got 4.59. I guess maybe the way to know that is, we're looking for FTA, and FTA is a horizontal force. So maybe when we do these problems in class that you go right to the horizontal, but that doesn't necessarily mean that you have to every time. I hope this helped. Again, hopefully you realize the principles here that the accelerations are 0. You want to draw your force diagram. You want to figure out your sine and cosine, and then go to horizontal and vertical. And based off your force diagram, you should be able to develop these force expressions off your force diagram. The rest, which is the math, is not nearly worth as much. I hope that helped, and thank you very much.